Example 3.5. Discuss the motion of an object under free fall. Neglect air resistance. So we have an object. Okay, we drop it from a height. What do we observe? We observe that the ball or whatever object it is falls down. Now this motion is accelerated. It is an accelerated motion and it's moving downwards due to the force of gravity. So this magnitude of acceleration due to gravity is given by G. Now, since we mentioned that air resistance is neglect air resistance. If the air resistance is negligible, the fall is said to be a free fall. We call the fall a free fall. Now, if this height that object is falling is very less compared to the orbit of the radius of the Earth's orbit, we see that G is a constant. G is acceleration due to gravity. It's a constant and its value is 9.8 meter per second square. Free fall is an example of uniform acceleration. Let's solve example 3.6. Galileo's law of odd numbers. The distances traversed during equal intervals of time by a body falling from rest stand to one another in the same ratio as the odd numbers beginning with unity. So you have to prove this. How do you prove this? We've got a body which is falling from rest. So we know the initial velocity is 0. Okay. In equal intervals of time. So if it equal intervals of time means each interval is just 1 second. The distance traveled in equal intervals of time. Right? So how do you represent this? We can mention it as t, 2t, from beginning with 0, 3t. So what is the time period here? T minus 0 is t. 2t minus t is t. So the equal period of time. We need to find the distance traveled in equal period of time. Find the and then find the ratio. Since this is a freely falling body, we can use the formula S equal to ut minus half at square. Sorry, v naught t minus half at gt square. So S will be equal to, this will be 0 since the initial velocity mentioned is 0. Got minus half g t square. So this is a formula which you have to use. Now let's solve this using this equation. So we've got at 0 time period. Okay, so this is time 0. This is distance x, s. So at 0 time, what will be the distance? 0. When time is equal to t, distance will be minus half g t square. What about when it is 2t? Then it will be minus half g t will be 2t the whole square, that is 4t square. 3t will be minus half g 9t square because it will be the square of 3, that is 9. 4t will be minus half g 16t square. Now suppose I mention this y naught to be equal to minus half gt square. This is just to simplify it. Okay. So what do we get? Here it will be 0. Here it will be y naught. Right? It will be y naught. Here it will be minus half g t square. The only thing difference is 4. So we get 4 y naught. Here it will be 9 y naught. Here it will be 16 y naught. To find out the distance traversed, how do we do that? In equal intervals of time. So t minus 0. In t seconds, how much distance has it traveled? It will be y naught minus 0. That is y naught. The next interval. Next interval will be from 2t to t. That is, in this period, what is the distance traveled? That will be 4 y naught minus y naught, 3 y naught. In between 3t to 2t, It is 9y0 minus 4y0 will be 5y0. Similarly, here it will be 7y0. Now, if we take the ratio of this, what do we get? Ratio Now, if we take the ratio of this, what do we get? Ratio is what? Simply the division between everything, right? So, what do we get? Here, all the y0s will get cancelled. We get the final value to be 1:3:5:7. And if we continue with the distances, it will go like this. So, we have proved it. It is in form of odd numbers. Question 3.7. Stopping distance of vehicles. When brakes are applied to a moving vehicle, the distance it travels before stopping is called stopping distance. It is an important factor for road safety and depends on the initial velocity v0 and the braking capacity or deceleration minus a that is caused by the braking. Derive an expression for stopping distance of a vehicle in terms of v0 and a. So let's solve this. So we know that the final velocity, right? The final velocity would be equal to 0 because it's coming to a stop, right? Initial velocity is v0. The acceleration here is negative a. Now we have to find an expression for the stopping distance. Let us take the stopping distance to be d. Okay? We need to find a relation between stopping distance d, initial velocity v0 and deceleration a. So let's solve this. So which equation of motion can be used for this? We can use v square equal to v0 square plus 2as. Now what is the final velocity here? 0. Initial velocity is v0 square minus, because it's deceleration, 2a. Stopping distance we've taken as d. So when we solve this, what do we get? We get v0 is equal to v0 square is equal to 2ad. Now what do we observe from this? We observe that the stopping distance d, we observe the relation between stopping distance d and initial velocity v0. And we see that the stopping distance depends on the square of the initial velocity. The stopping distance is directly proportional to the square of the initial velocity. That's question 3.7.